Problem number 10 says, find a function f and a positive real number a such that 1 plus the integral from a to x of f of t divided by t to the fifth power with respect to t is equal to 5x to the power of negative 3. And so we should first start by taking the derivative of both sides. And so when we differentiate the left side, the derivative of 1 is just 0, and the derivative of this integral by the first fundamental theorem of calculus becomes f of x divided by x to the power of 5, and this is equal to, when we differentiate, we bring the when we differentiate the right hand side, we bring the exponent down, and so we have 5 times negative 3, or negative 15. And the power subtracts by 1, and so we would have x to the negative 4. And now when we solve for the function f, we multiply both sides by now to solve for the function f, we multiply both sides by x to the power of 5. And what we end up getting is our function f of x is equal to negative 15x. And so now we have to try to find our specific a value. And so what we should do is plug in our f of x, but instead the variable is t in this case, so our x will be replaced with a t. And so I would replace f of t, or I would replace f of t up here with negative 15t. Divided by t to the fifth power dt. And this is equal to 5x to the negative third power. Well, this also means that 1 minus 15 times the integral from a to x of t divided by t to the fifth power is just t to the negative fourth power. And this is still equal to 5x to the negative third power. Well, when we take the antiderivative of this by using the power rule, we add 1, so this would become a negative 3, but we also have to divide by that. So now we have 1 minus 15 divided by negative 3 t to the negative third power. And we're evaluating from a to x on this side. Well, now we just have 1 plus 5, and when we plug in our x value, we have x to the negative third power, and then we have to subtract a 5a to the negative third power. And this is supposed to still be equal to 5x to the negative third power. Well, observe that this is the same as this, and so these actually cancel out, and so we have, I'll move my work over here, we have 1 minus 5a to the negative third power equal to 0. Well, now we can say 1 is equal to 5a to the negative third power. And we can divide both sides by 5, so 1/5 is equal to a to the negative third power. Or this is like the same thing as saying a cubed is equal to 5. And so if we take the cube root of both sides, we get a equals the cube root of 5. And so now we have our function and we have our specific a value.